Guys, we've got some Rocco's Pizza here. Kind of a fun problem. It's already doing business selling medium pizzas at a certain price, and then it's kind of considering during a slow month as to whether or not they can throw out this special that they're going to run, like two pizzas for the price of one. And so let's take a look at the numbers here. It's interesting that if you have a medium pizza price here of $11.99, we have they give us this variable expense of $4, and that means the contribution on pizza here is $7.99, and they give us this volume figure. In other words, right now they're doing $400 volume orders, if you will, or they get 400 of these. So this is the amount of money they're bringing in on that. Okay, so that's the amount of contribution that is then going toward your fixed cost and your operating income. So with that, you may not have a whole lot of operating income because your fixed costs could be up there. But anyway, you're proposing that you would run a special, right, where you they could be taking the price of the pizza, giving them a pizza, and then adding a penny. So if you do that and you divide it by two, and you're talking about $6. Now all of a sudden, the revenue is dropping from $1.99 down to $6. Now that's what students miss the most. It's like, whoa, wait a minute. You're going to give them two for one. That means that the price goes almost in half, doesn't it? So that means the revenue amount per unit goes way down, but your variable expenses, as long as you're not cheating people, it's going to still be the same, right? You're going to put the same amount of toppings on that particular pizza. So your contribution margin then is going to drop to $2 per person, right? Per order, right? Per pizza. I'm sorry, excuse me. So if you take that $2 and you divide it into this 31.96, how many orders do we need, right, to bring in the same amount of money? Well, the orders we need is 799. So if you divide it by two here, guys, because you're giving two pizzas for one, right? So, but you'll notice that the volume has to literally double, almost double, right? I mean, is this more? What is this? 300? No, it's nearly 400 more. So, you have to literally be able to forecast that you can double your business, the amount of people that are contacting your business, right? So can you do that? That's the big question. That's a tough looking number there. But if you guys with pizza realize that every third customer, for example, orders more than one drink with their pizza, right? You can sort of project how many drinks that might be an increase might bring. And if you know that like one out of every five or one out of every seven or one out of every eight customers will also order a salad as well, or they'll order some mozzarella cheese sticks, or they're going to come up with some, or you got some wings at your pizza restaurant. So they're going to order something more than that, especially if they think they're getting a deal on the pizza. So they're going to order something else. There's definitely an incentive there. So the point is though is that these people can have different contribution margins on those different products, and you can make a pretty close projection knowing the basically the activity, the behavior of your customers, and how many of them would probably bring home additional product from your store. So you have to consider that in any kind of subjective decision as to whether or not to run this kind of a special. You certainly want to add that to this to see if it is feasible for you to be able to make a little money and get the volume up in the month of May, right? So anyway, that's kind of a fun problem. I just know that the profit margin that's on pizza is extremely good. Contribution is high, and so that's why you see so many eateries out there. I mean, there's a bunch, and that's why they have money for advertisement. Pizza and Domino's delivery. And they have Domino's out fixing roads now, for the potholes and stuff. So it's amazing they can do that, but they can because they have a very, very high contribution margin, a good product to try to sell. That's why so many people go into it. Guys, we're going to scroll down to 1220, and we're going to talk here about mixed cost. Guys, if you have a set of costs that you have run up for a level of production, it's not always easy to separate between variable and fixed cost. So in this particular problem, we have two different production levels. I want you to notice this. 10,000 and 20,000. These are two different production levels. And we know, and we've been able to identify that $2.40 per unit is variable. And we know that by dividing 10,000 into the 24 that they give us, okay? And we can then use that $2.40 for the 20,000 units and get this 48 here. So that's kind of been put in there for you instead of a question mark like in the text there. And then we know, of course, that in February the fixed cost is the same as in August. So we put this, just move this amount over here. Okay, and then if we take this 118 and subtract out the 48 and the 36, we're going to get 34 for the mixed cost. Now that means we have a mixed cost in February for 20,000, and we have a mixed cost in August for 34,000. Now you know that some of this cost has got to be variable because you got an increase in units and you got an increase in cost, but you just don't know how much. So we're going to go down here and kind of take a look at this, and we're going to see, right? We're going to take that 34,000 under 20,000 units and subtract out. That's your high, right? The high level of production. And then you subtract out your low level of production, this 10,000 units of 20,000. And then we're going to divide that by the change in that production level, which is 10,000. So we take 14 and divide it by 10,000, and we get $1.40 per unit. Now, let me just tell you what that tells you. It tells you what the change in units are, right, as they fluctuate. Right? So we know or suspect here real strongly, right, that $1.40 is the amount of variable per unit. So let's just calculate this. Let's plug it in and see if it works. So let's go to 10,000 units and multiply that $1.40, and we get 14,000. Then, guys, if we take that 20,000 at 10,000 level unit now, at 20,000 of mixed cost, subtract out what we know is variable, we're going to get 6,000 in fixed. Right? Well, you know how we can check that to see whether or not it's right? We can also plug in the same calculation for 20,000 units. Now look, this $1.40 times 20,000 units is 28,000. And then look here, if we take the 34 and subtract out that 28, we're going to get 6,000. So what does this tell us? It tells us that 6,000 of these two amounts right here are fixed, and the rest of it's variable. Now you can also put that into, scroll down here, a cost formula, right? 6,000 for just, now this is a cost formula for just your mixed cost. And you could take that 6,000 and then add it to the variable times the volume. So then they give us an example. They say, okay, well, tell us what our costs are if we run 6,000 units. Well, we can take these numbers. We can take the 240 per unit times 16,000 and get this 38,400, and then we know the fixed costs are 36. And then we can take a linear formula here, 6,000 plus 16,000 units at 40, and we know our mixed cost then will be 28,400 for a total cost of 102,800. Now, if you look up here, you'll see that that's in between the 80,000 total cost and the 118,000 total cost. And that's because the number of units is in between these two. So this is the cost that you would have if you had 16,000 units. Now, there's a couple of assumptions that you make here, and that is that the cost behavior has a pattern to it. It's linear. It can be calculated, is what that really means. And that we have a relevant range. In other words, there is a certain amount of capacity that we can run in production. So if you run a certain relevant range with a certain set number of fixed costs, and you can run different production levels, you can figure out any kind of projection for the next month as far as your cost is concerned, based on what you think the units are that you need to produce. So this is all tied in later with the budgeting chapter, guys. But this is something that you have to kind of understand and know. And it's very simple calculation, but get into Connect and get yourself used to just plugging in these numbers and coming up with this cost formula. You'll be fine on the test.